Again, there is a technical glitch. Let me continue. So the pressure at this point A, we have taken, since it is vacuum here, the pressure is 0. The pressure at point A is 0. Now let us move forward and find out what is the pressure at this point here. Let us say this point is X, let us say. The pressure at X will be due to the mercury column. So this is the whole thing is mercury, Hg, so due to the mercury column. If I take a point outside this here, and here what is the pressure? If I wanted to know, again it is because of atmospheric pressure here. So I can conclude the pressure at the point X will be equal to the pressure at the point Y because they lie in the same horizontal line. So if I know what is the liquid pressure, the mercury pressure, I know the atmospheric pressure, P atmosphere at this point. So how can we do this? Because they both lie in the same line. Or if I take choose another point Z, which is also following in the same horizontal line, here also pressure is acting. The whole surrounding is with atmosphere. So atmospheric pressure is going to act. So I can say here also same atmospheric pressure is there. So pressure at X will be equal to Y and equal to Z. That is, the liquid pressure is equal to the atmospheric pressure. Yes. So what is the formula for liquid pressure? P is equal to H rho G. H is the height of the liquid column. Here the liquid column height is 76 centimeter. But we want it in SI unit. So we convert it and divide by 100 and the centimeter will become meter. Multiplied by rho density. Which is the liquid you have? Mercury. What is the density of mercury? That is 13.6 gram per cubic centimeter. Again SI unit. So 13.6 into 10 power 3 kg per meter cube. Multiplied by G, acceleration due to gravity, 9.8 meter per second square. When you multiply all these things, you will arrive at a number 1.013 Pascal. Okay, this is the into 10 power 5 Pascal. Okay, this is the atmospheric pressure. The pressure, atmospheric pressure is approximately equal to 10 power 5 Pascal at sea level. At sea level, the atmospheric pressure is 10 power 5 Pascal. So 10 power 5 Pascal is equal to, in other words, 76 centimeter of mercury. Either way you can say this represents one and the same. Here we have substituted the values and we have arrived at this number. So this barometer measures atmospheric pressure. So pressure due to the liquid is 10 power 5 here, which means the pressure due to the atmosphere is 10 power 5 here, and that is what it is saying. But remember one thing, that this is not a perfect barometer. This barometer is not convenient to carry anywhere. It is not compact, and the impurities can fall and the glass can break. So all these are not possible. It is just a scientific invention, a beginning of something. Now we have more modern better barometers that has been carried in the aeroplane and all to know atmospheric pressure at a particular point. So this is only a starting point of it. So I wanted to say something here, a point which I wanted to say. This is also referred to as 1 bar. It is also called 1 bar, BAR. So how does this atmospheric pressure, you know that atmospheric pressure is due to the layer of air surrounding the earth. Earth is there, right? And there is a strong layer of air around the earth. Okay, and now this layer is going to apply a pressure on objects on the earth, and that is called atmospheric pressure. Now, what is normally atmospheric pressure? 10 power 5 Pascal, that is 1 lakh Pascal. 1 lakh Pascal. Don't you think 1 lakh Pascal is a very big amount? Such a big pressure is acting on every object on the earth. Now look at us. We are their human being. On us also it is acting. Think you are keeping a very big block of box keeping on your head. Think so much it will crush us. But how are we not getting crushed? We are not getting crushed because, you know, inside our body, our heart is pumping the blood. Okay, this pumping of the blood causes blood pressure. And that blood pressure is compensating, is keeping us in equilibrium with the external pressure. Though the atmosphere may try to push down, compress the body, but the heart is pumping the blood, and that is blood pressure, and that blood pressure is able to compensate equal and opposite pressures. Now, normally human being will say 120 mm of mercury. This is known as systolic pressure. Systolic pressure. Okay, for normally, right? And 80 mm, the lower value, 80 mm of mercury, this is called diastolic. Diastolic. Right? This is a lower value. So doctors will write 120, 80. This is usually normal value. That doesn't mean that everyone will have only 120, 80. No. It depends on the body, the constitution, and all the other factors. For example, it can be, for some people, 130, 90 can be normal. 110, 70 can be normal. So it can be anything. For example, my blood pressure is 130, 90. That is usually normal for me. Someone else, I know that person is only 110, 70. So we cannot judge like that. You feel normal, you're okay. The blood pressure can be any of the number. It can vary. But usually in standard, we say 120, 80. So this is how we are going to. So I also want to tell you a particular unit that is called 1 mm of mercury. This is called TORR. TOR. The word comes from Torricelli, right? To remember that scientist, TOR. What is 1 TOR? That is 1 mm of mercury. That is just another unit you are going to have. Sometimes they will express it in dynes also, right? Newton, dyne. So conversions, you can learn it easily. So this is the general idea of a barometer, generally which measures atmospheric pressure. And this is the first step of it. That is a mercury barometer. And the liquid column, the pressure due to that is compared with that of the atmospheric pressure, and we are able to measure. In the further next classes, we will try to learn more about other chapters like Archimedes' principle. I would like to give you a small question to you, right? Just a small question which I will put it for you. You think of it and then you can write it in the comments section for me. If I take a tube, right, and I fill it with water, and I take a container also of water. See, this liquid is also water. Mercury, water. I invert this like this, and it is going to come to some particular level. In a barometer which is using water as a liquid, what will be the height of the column? What will be the height of the column, or what should be the length of the tube, minimum length which you should take, so that it is able to suspend it, so that atmospheric pressure is able to match to that of this. Remember, the liquid you are taking here is water instead of mercury. Try it and then do it the problem. Use P is equal to H rho G. I'll give you one thing. Rho, density of water is 1 gram per cubic centimeter, which is nothing but 10 power 3 kg per meter cube. Use this and then calculate. And you know very well atmospheric pressure is 10 power 5 Pascal. We have done it, and calculate and write it in the comment section once you have completed. Thank you so much.